This is the problem solving session of lecture 4. I have to get used to the new board on wave mechanics. Part 2. I'll do four questions. There are a lot of questions at the for this chapter at the back of the book. Let me count how many. 17. So I'll do about a quarter of them. 2 mathy type, more of the harder ones, in case you have trouble on the math, and 2 physics type questions. And some of these questions are quite difficult, so be warned. Alright, the 2 math type questions are concerned with the Hermite or Hermite, if you anglicize it, polynomials. And you're given a generating function. You're told if you expand this out in powers of s, then the coefficients of that power of s is the Hermite or Hermite polynomial divided by n factorial. So what you're asked to do is to take this left hand side and expand it out up to powers of s to the 5, okay? And then from that, by equating left hand side and right hand side for the coefficients of powers of s, so s to the first power, s to the second power, and so on, find these Hermite polynomials. Right? So find h0, h1, ... up to h5. Now it's a 2-part question, because once you've found these, you're then asked to check using this different formula. So this is like using this is a generating function, because it generates the terms that you're looking for. And here's an alternative way, using differentials. So you're just differentiating multiple times. By differentiating e to the minus z squared, and you're to do this for these. Well, I don't think I actually did it all 5. For the check, I think I went up to 3, but you'll get the point, right? So it's a 2-part question. So let's start with the first part. So you're asked to expand this in powers of s up to including s to the fifth power. So have a look at this. You can split this up. You can rewrite this in 2 forms. It allows you to expand things more easily. So I assume you know the expansion formula for exponential. So I'll just say it verbally. So e to the x equals 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the 5th over 5 factorial. And I don't need to go any further, because we're just asked for the 5th power, right? Okay, so e to the minus s squared, just so look on minus s squared as x, so you just get 1 plus x squared over 2 factorial. I won't go to the 3rd, because that'll be s to the 6th, and I don't need that. So this is as far as I need to go to expand this e to the minus s squared. Okay, and now expand this. It only has a single s in here, so we'll need to expand a few more terms. So it'll be 1 plus x squared over 2 plus x squared over 3 ... In this case, x is 2sz. So here's your x, just 2sz, and then you square it over 2, so 4s squared z squared over 2, and then you cube it, so 8s cubed z cubed over 3 factorial, so that's 6, and then to the 4th power, so 16s to the 4th z to the 4th over 4 factorial, so that's 24, okay, and then to the 5th power, this, so 2, 4, 8, 16, 32 s to the 5th z to the 5th over 5 factorial, which is 120, okay, plus ... But I don't need to go any further, because we're talking about powers to the fifth, right? Now collect terms. Collect the coefficients of a particular power of s. So there's only one unit, one digit, so it's just 1. And then what are the powers of s? S to the 1. It'll just be this one, multiplied by 1. So you get 2sz. Right? Now collect terms for s squared. You get a minus 1 from these two, and you'll get a plus 4z squared over 2, in other words 2z squared from these two. Right? So you've got two terms there for s squared. Now for s cubed, if you multiply these two, you get an s cubed. And if you multiply that and that, you get an s cubed. So two terms there. So s cubed. Where's this 4 over 3 come from? Oh, I see. So it's this times that. Okay, so it's 4 over 3 s cubed, z cubed. That's that term, and another cubed from here and here. So you get minus 2z s cubed. Okay, alright. Now I'll collect the s to the fourth terms. So you'll get one of them from here, 1 times this, and s to the fourth. So these two together, multiply, will give you s to the fourth. So let's see. So divide both sides, top and bottom by 8. So you'll get 2/3. That's here. C to the fourth. So that's that term here. And this one and this one. So that's minus 2z squared s to the fourth. Okay. Now s to the fifth. Let's see, it'll be that times that, so that's, well, you can simplify that down, divide top and bottom by 8, so you get 4 over 15, so 4 over 15, z to the fifth, okay. How else can you get s to the fifth? These two, so minus here, so minus 4 over 3z cubed, that's where this term comes from. And how else? These two. So well, the 2's cancel, so you just get plus z, just plus z. Okay. Right? Now, okay, so we've got our terms. We know the coefficients of s, it's just 2z. So h naught will be just 1. Okay, we just read off the coefficients. So this is power s to the naught, right? So just 1. So h naught is just 1 from here. h1. If you look at these powers, so h1 will just be 2z, so h1 is 2z. Now in the textbook they list the first 4, I think, ME polynomials, and the first 4 terms I found agree with the text.